Let's start. Good evening, everyone. Welcome to 8th live session for the course Functional and Conceptual Design. And my name is Neelarnab Dutta. I am a PMRF fellow and a PhD scholar from the Department of Design, IIT Guwahati. So, in this particular class, I will try to clarify some of the important concepts that will be useful for you in solving the assignments for week 8. So have you gone through week 8 assignments, or have you gone through week 8 lecture videos? The deadline for assignment is tomorrow, that is 21st September. So if you have not finished it, you please finish it on time. And since nature of the assignments are objectives, so this class I cannot take directly solving the assignments. So I will try to cover some of the key concepts that will be helpful for you guys to solve the assignments. Okay. So what we learned in the last class was about functional decomposition, and previous to the last class we learned about simple techniques of functional decomposition, which were like fast and the SOP method. Okay. However, those methods have limitation as they are useful only for simple products, and as the complexity of products increases we need more robust method. Sorry for the interruption. Okay, so we need more robust method like flow model. Okay, which can be used to functional which can be used for functional decomposition of complex products. So what I covered in the last class was something called functional common basis, which is basically some primitive verb and noun that we use to reach a functional decomposition endpoint. So the nature of uh, the way we write the functions are in the form of a verb plus noun. For example, rotate, blade. Okay. So there are a list of functional common basis, and if you can reach your functional decompositions, your functions to something particular to that list, then we can realize that we have reached the end point in the functional decomposition process. We discussed about flow model, which is a robust method used for complex product, and what we learned in that particular model was that a system can be conceptualized as a black box. Okay, and there are flow of elements and there are flow out of elements, and what we consider as elements were energy. So there are some form of energy that will go in to a system, and the system will output another form of energy. For example, if you are making as if you are considering a product like a electric saver. Okay, so as an energy you are giving electrical energy, and as an output you are generating some sort of mechanical or sound energy. So sound, so vibrational sound energy, the energy as a heat, temperature, the energy of the torque that is used for cutting beard. So those are the form of energy we can get as output. Similarly, material can be an input, which will flow to the system, and there are some form of material that will be out. So for example, here in terms of material, we have something like an adjustable aperture in the front, which helps in determining the length of cutting. Similarly, at the output, we can have the same material that we will remove. Similarly, as an input, we can say hair, okay, as a material that is going in, and what as an output we get, the cut hair. The other form of flow can be information or signal. So in a saver, this can be like the user input in terms of button, switch on, switch off, and the output can be the operation, okay, and which will give a signal by giving that sound, particular sound energy, sound signal. So these were three types of inputs and outputs we discussed in the flow model. And once we arrive at these input outputs at the initial phase, then we started analyzing the requirements inside the system. So how this particular energy can be converted into this particular energy. Similarly, how this particular material can be used and used within the system to come up with this particular material output. Similarly, how particular information signal is used within the system and to generate the output signal. So this was how functional flow diagram works that I did discussed in the last class. And based on that, what we generated was a function structure. So a function structure is a bit complex than a tree structure. So tree structure we discussed initially for fast and SOP method for defining a functional subtree. So you have a high level function, then we have sub functions, then again you have level 2 sub functions. However, this is only useful for simple products which have only one critical function part. But in case of complex products, for example, I discussed about sachet dispenser in the last class. Now you might have multiple critical parts. So you may have overall product functional goal, and there can be multiple functional critical part, critical function part, and these only can be derived using this sort of flow model. And we realize that the structure, this is not a tree structure, this is more like a complex structure having interrelationship between different critical function part, okay. And at the end we briefly discussed about product architecture, and I will continue the discussion today. So basically, where are we in this class is that, like, initially we come up with needs, okay, user needs, then we come up with product specifications, okay, then we decided based on product specifications which are constraints and which are functions, and then we discussed about how these functions can be derived into further sub functions using functional decomposition methods like fast, SOP, and this rule, the flow model, okay. Then at the end we end up with having some sort of function tree or a structure, okay. But the next question is how to come up with some sort of product architecture using this function model. So basically there are two types of product architecture. One is related to particular products, which are like how a product architecture is defined inside a product. For example, if a product is a watch, so probably a watch have inside, if it's a digital watch, it will have a timekeeping hardware, which is a which is called a RTOS. Then there are batteries, okay? And there are some sort of microcontroller unit which will take care of various other functionalities. Okay, so this is how you decide the internal architecture of a product. And the other kind of product architecture is family architecture. So basically, we when we see products in the market, they does not have only one particular product architecture. They have family of products, and they have some shared commonality among their products. For example, a particular company like Tanisk or Titan, they may have a product lineup of their watches having some sort of similarities and some sort of differentiation. And in this particular lecture, I'll be discussing how to choose a particular product architecture and how companies decide whether to go for different product architectures, how to go about different product architectures. So have you gone through the lecture videos of week 8 course content?
Yes, yes,
Okay.
gone through.
Okay, so basically, the things that you consider in product architecture is the cost, okay, and the revenue, and this is helpful for you deciding how many different products you require a company need to place in the market. So this is from the perspective of the commercialization, the profitability of a product line. So companies decide what are various different user segments, what are different needs, and based on that how many different products, family of products should be there in the market. Okay, so that's one consideration. Another consideration is like when designing components and subsystems, you need to keep in mind whether you are going to use particular component or subsystem in future. So you need to consider both the current need as well as future requirements. For example, you may carry on a particular dial probably to your future product lineup. So people do that if you consider complex product like a bike, you may see the console, okay, and they use the same console or the same tank in different bikes. So within their family of products, they use similar subsystem or components. So that also you need to decide. And the other part is reusable subsystem. So reusable subsystem means whenever you are designing something, then you need to think like how this can be used again in the future. Okay, so this is more related to deciding on subsystem, how when you are designing a subsystem how this can be reused, and this is more like how to consider needs. Okay, the user needs. So you may consider similar user needs in the future as well as in the current state. Clear? Okay,
Yeah,
so what we have in product art portfolio, there are three different types of product architectures. One is fixed unshared product architectures, which are basically does not have any variation in the product lineup. And for example, if we consider something like a screwdriver, okay, and you may have screwdrivers of different size and shape, except the design, which is like the conceptual part. As a subsystem, nothing can be carried forward. So you need to consider different size of thickness of the material, the metal part. There you need to consider different size of the handle part. You need to consider different size of the tip part. So in case of such products, there is no shared commonality. So those are called fixed unshared products. Okay, and there are two types of, again, those can be subdivided into two categories. One is single offer, and there is adaptable offer. Single offer is what I already discussed about screwdrivers. Whenever you design something, there is nothing you can carry forward in the subsequent design, so everything is like one at a go. You can have like many in terms of color. Okay, so those are qualitative. In terms of color, ergonomics, you can have some sort of variations, but in terms of functional elements, you cannot use particular components. So I'm talking this thing from the functional perspective. So when you divide a product, a higher functional function to a sub functions, what we're saying that these sub functions cannot be used you know in another products of the same family. Again, the next is adaptable offer. So what is adaptable offer is like, you have a product which is unique, but there are some sort of adaptability you need to provide. For example, if you consider a charger. Okay, so in Indian setting we have these cylindrical charging points. However, if you go to European countries, they have something like a flat design. So there are some small adaptability you need to provide, although the major functionality of the product is fixed. So this is the second category. The another category is the modular platforms. So basically, this is the most common varieties, the common form of product architecture which we come to realize in the market. For example, if you consider anything like a bike, or anything like a washing machine, mixer grinder, any products, so they have something like a reusable. So in case of a mixer grinder, you will see the vessels are reusable. In most of the cases, they do not redesign the top vessels again and again. So they may have some variations in the form, the below shape or below functionalities, but there are variations. They do not provide any sort of variation, so they use same modality for grinding or making juice. So this is what we are discussing here as modular platforms. And this modular platform architecture have again five different categories. So the very common is modular family. Okay, so depending upon different customer segments, so if you have really distinct customer segments, then you make you release parallel products in the market. So for example, some person may think about having a grinder with a juicer. So this is like a mixer with a juicer, and this is only a mixer, and they need to release these two products at the same time because there's a demand for both the particular products. However, if you only sell this particular product, some people may not buy this because this will add to the cost. Okay, this will be expensive than this, and some people may not want to have a juicer. Additionally, some people only need something to grind, for example, to make their dosas or some stuff. So and if there are different customer segments, then you go for different products. And what is common there, they generally used some common parts subsystems which can be actually carry forward. So maybe the knob, the inside motor which is used for grinding, so the inside architecture may be also same. But for the juicer, they may provide something additional, something like a new attachment. which can be used same system for juicer. So okay, so when so we make those decisions, okay, sometimes, okay, so there are several factors that actually affect that. One is like when there are different needs, okay, different needs and clear customer segments. So sorry, not clear, varying. So you have different set of requirements and there are varying customer segments. So one group require this, another group require this, so you need to provide such a family of products. Okay. The another can be cost sensitivity. Some people might look for something in the lower price range, so in those can be also deciding factor when you want to release some variation which is a bit cheaper. This you will see generally in bikes, so you or in the cars you have the DLX, then the top variant, so like that. So you have in the bikes also, in the cars also, you have different variants and they have different features, but in most of the cases the base features are same, but there are some sort of added features and there are variations, and the main goal is to reduce cost. Okay, so cost sensitivity or reducing cost. So this is a deciding factor. And sometimes you want to extend the product lineup in order to introduce new features. So which is like enhancing product feature. So these are various deciding factors which actually one needs to consider while deciding modular family architecture of products. The another kind of product architecture is modular generation. So, do you know what is modular generation?
Yeah, like modular generation is something like if suppose customer need is changing throughout the time, or maybe after 2 years if their demand is changing. So to meet that requirement, we change little bit in product and we like mitigate their requirement.
Yes. So basically, for example, you can consider the case of a camera. Okay. So if some particular subsystem have some sort of incremental change in the requirement. Okay. So you just modify that small subsystem in the next generation, and but the rest of the product remain the same. So this kind of product portfolio you call as modular generation. And then what is modular consumable?
Modular consumable is something like if suppose if we think about film or what I'm forgetting the name. Anyway, uh, just give me some.
Okay, so modular
Like
consumable.
film camera, like we are changing the films, right? And
Okay.
inkjet printer, like we put new inkjet inside it. It's a kind of consumable item for that product,
Okay.
which can fit into it.
Okay, so basically the here you need to consider one thing, that cartridge is not the product, but the printer that is designed around to accept that particular cartridge is the family of products. Okay, they are using the same consumables. So you can have different versions. For example, one printer may have scanner, and this one have just the printer, but they use the same cartridge. So these are called as modular consumable products. Okay, then what is modular standard? Okay, so
In
modular.
PC, if you are adding some bus connector or something.
Okay, so modular standard means while manufacturing your products, you have different products, right? You are standardizing your products by using some sort of standard components, some sort of standard architecture. Then those are called modular standard products. For example, you are using a similar bus structure. For example, in your PC you use DDR2 RAM, right? So DDR2 RAM certain have some sort of slots. Okay, this cannot match say DDR3 RAM. Probably DDR3 will have some different slot that will go inside. So when you design your products by using some sort of standards, you are actually easing out a lot of extra effort in redesigning some of the basic standard subcomponents, and which will help in reducing cost and cost of research. Okay, so this way of deciding products is called modular standard product architecture.
My question is here. So, in terms of RAM, you are just a standard. Sorry, they are just formulating like modulating that margin, but you're looking at, right?
Yes, so what happens, see, if when you use standards, you do not have to go back to your design from scratch. You don't have to decide anything. You do not have to design or plan things from scratch. You can use standard practices, standard architecture in your design to come up with a portfolio of products. Okay, so that may include the bar structure, that may include your the RAM, physical RAM architecture. Okay, so you say
Mm.
these three products use DDR3. Okay, so that means these now share a common standard architecture. Okay, so they come under a similar modular platform. So you have a where the modularity lies in terms of standards. Okay, using standard uh, subsystem or some standard components or standard architecture. Clear?
But modular itself is something like we are using certain subsystem and we are changing little subsystem of it and we are getting a new product or new output. So how you clearly categorize a modular standard here? Because modular bed will say we obviously look for like obviously we carry forward the thing which already set up.
Yes, yes. So what happened, like when see modular can be, okay, this is a system and you have one and two. Let's say one, the component one is a modular component and you are carry forward this to this thing. Okay, now this is have a three part, but one is common, then these are modular. Okay, I'm saying
Hmm.
if this one, if it is a standard component or sub function, then it is called as modular standard.
Can we just asking? Can you give me little some other example than the RAM?
Okay, let me give a
In modular
answer.
standard, what else will come other than RAM?
So if it is not modular, that means you are designing, although you are using a particular subsystem, you need to think about others, other, the feasibility of interoperability between the various functionalities. Okay, did you get that? So for example, if you custom made this particular part, okay, for example, for your juicer, okay, this is a good
Hmm.
example. So juicer, see, this part is a common part, okay. You have two different version of juicer, and this is a common, and you are saying these are modular family. But this particular product is not a standard component. Across various companies this particular product may vary, but within your company this is a standard, this is something common, right? Here I am
So
saying,
basically, you are telling about in particular company, certain thing is a standard. Like when we talk about any, because I'm an architecture, so I can give you the example of interior. Like we design kitchen, but certain thing is very like a standard. Like when we talk about modules, it will keep it 600 width, height 600 or maybe 720. So
mhm,
within that, will fit different organizer, or all the other equipment in that to enhance the customer experience while
mhm.
using that. So is that so modular standard is?
No, no, no. So that means for your company, that is a standard part. So you do not call that as a standard. You call it is your company's proprietary product, right? So you say
Okay.
this particular product is your proprietary product, and you use this common across different version of your product. However, there are some components which you will use across all variations. For example, imagine this particular knob, and
Mhm.
the behind the knob you have a some sort of some sort of
Mechanism.
encoder, right? Some sort of
Yeah.
resistive encoder. So that is what I'm saying as standard.
Okay, okay, understood. Now I think I got it.
Okay, so this
Yeah,
kind of
thank you so much.
variation you can do as modular variations. And when you come as standards, so across various companies
That,
globally, you are using some sort of standard components and subsystems. Okay.
yeah. Maybe the RAM slot you are talking about, it will be common throughout the product.
Yes, yes. So when I'm saying DDR3 RAM slot, that means this is common across all sort of companies. Whether you consider Apple, Mac, any company, this is something standard practice. Okay.
Okay, thank
So
you.
these are just classification, categorization of various products. How you can categorize, the products groups into different families. Okay. The last one is modular parametric. If I give a same example, you will see if you may get a little confused, but here the point is like when you are actually providing some sort of modularity, you are also making sure that that particular modular unit have some sort of some sort of user controlled parameter setting. So user can choose some sort of parameter in that particular modular unit. So RAM is again can be an example. So for example, you have provided a slot. You can choose either 256 MB or 1 GB. It is up to you. So your design is basically modular parametric. This is standard also. This is parametric also. For example, if I give a second example as a screwdriver, okay. So screwdriver, there are fixed, uh, design. So you can say M3 screwdriver. Okay? So within M3 you cannot put M6. Okay. However, you can choose M3 of having a longer thread. Okay. So that may be, so that particular parameter is length of the screw. And if that's a desired thing within your system, then you can consider that as a parametric change in your module. Clear? Hello.
Yes, yes, I can hear you.
Okay, sorry for the interruption. So I was discussing about parametric, modular parametric product architecture. Okay, so where I was discussing that when you are designing different products, you can have some modular unit subsystem. However, still you can have some sort of parametric control, variation in this particular unit. So for a computer, a RAM slot can be a standard. However, a RAM itself can come up with different values. So you can have 1 GB RAM, 4 GB RAM, similarly hard disk. Okay, so designing a system which is capable of providing modules and user have a control over some sort of parametric change, what we call as modular parametric architecture. Clear?
Yeah, yeah, clear.
Okay. The other kind at a high level is customizable. So what happens sometimes, uh, you have a very small group of population, okay, where producing products in a large scale is not economical for a company, or there can be other issues like there are a lot of variation in terms of parameters. For example, if you are talking about knee implants, okay, and if you are talking about some sort of biomedical support for your soldiers, so you need some sort of customizability in those products, and you cannot design uh, you know something concrete and fixed in those cases. So this happens in two cases: one, whether if you have a very small population; the other happens when you have lot of variation. So within the population, if you have lot of different needs, so many people may have different requirements, so it is not possible to provide one particular solution, okay, to capture the requirement of all the population. So in those cases, we go for something like a customizable products. So in customizable product, we have again two kind. One is bespoke, which is at the time of designing, uh, it is customized as per user requirements. The other one is it is designed for general use. However, it has some sort of functionality so that it can be adjustable for different population or different purpose. Okay, clear?
Yes, yes.
Okay. Okay, so these are the different portfolio architectures that you know, we come across. However, one needs to know how to choose. Okay, choose between these various architecture types, okay, for your particular product. Okay, so for that purpose we use something called architecture selection flowchart. Okay, so in this particular, this is not a flowchart. The flowchart will come next, but this is a particular process where we gather some sort of statistical information. So what are those informations we consider? One is the no, central tendency or the measure. So I'll explain what is this. So this is like mean, median, mode, okay? And the other is the variation, okay, which can be denoted statistically by sigma, which is called standard deviation. Okay, so do you know how to calculate mean, median, mode, or standard deviation?
No, exactly. I forgot and all.
Okay.
Yeah.
So let me give an example. Probably this will help you understand. So imagine you have a pencil and you want to understand. So what is the average length of a pencil? New pencil, like when you buy it first time from a store, from a stationery shop. What is the average length? So what you do is you measure length of various pencils. Probably you go to different stores, you collect some thousand pencils and measure their lengths. Okay, so this thousand pencil is called population. So the population size, this is not human population, but we call statistically this is as population size. Population size is 1,000. That means you measured 1,000, you know, populations. Okay. So actually this is sample size. This is not population size, but I don't want to go to that detail. But for simplicity, I'm here explaining this is as a population. Population basically means all pencils in the world, which is not possible to measure. Okay. So you are considering a sample as a population for
Okay.
convenience.
Yeah, yeah.
Okay, so if you're considering 1,000, then you measure, for example, 5 centimeter. You know, some pencils are 10 centimeter, some pencils are like 7.5. Like that, you add all those 1,000 pencils and you divide them with 1,000. Okay. So you got a measure, right? That's what is called mean. Probably you get something like a 7.5 centimeter, and that is basically the average or the mean. Okay, it's a very common thing, like everyone knows these things. Now now pencil measurement is a quantitative measure. That's why you can add up, but product features may not be always quantitative. Okay, for example, your need can be something like qualitative in nature. Okay, for example, uh, if I say the what is the preference of a watch face between circular versus a rectangular. Okay, so how will you measure the mean? Okay, the mean choice. Okay, like this is very similar to this, but you now have a two variable. One is rectangular, one is circular. So these are not quantitative unit. You don't have something like, you cannot define this using some area. You cannot use area, right? Area doesn't define the shapes. So you are using something like a qualitative function, qualitative parameter. So in those cases, you cannot use actually mean. So if you want to understand what is average population like, okay, between a rectangular or circular, what you consider is like you again go for 1,000 population. You ask them which one you like. Probably you say one person say first, I want rectangular. The second person say circular. So like that, this 1,000 person may at the end the 1,000 person may say rectangular. Now how to analyze the data? So what is the central tendency, or what is the mean? Okay, so now we do not consider mean here. What we consider here is something called mode. Very similar. For mean is something for quantitative data. Mode is something important for qualitative data. Mode means the frequency. That means, for example, here, if 600 out of 1,000, 6,000 people say I like the rectangular watch, that means the mode is 600, because the 400 is less, which is circular. So we define this is like the mode is 600. That means the average, desire, this shape of a desire for a shape of a watch is a rectangular, and we define it by something called a mode. Similarly, median is again used for quantitative data, but that is when we do not want to measure something, but we want to count something. Okay, okay, okay. So mean, median, mode are measure of central tendency. So you have a population. So this is generally denoted by a bell curve. This is something like a bell shape. That's why it's called a bell curve. So the most common, like for example, the average, that means many people have said that 7.5 centimeters should be the length of a pencil. That means this is the point where it says the maximum. Okay. So this particular axis define the length, and this is the population, the size. And people who say that it is less than 7.5 are here. Okay, there are less people, and people who say it is more than 7.5 are lies here. And this variance, like a distribution, like okay, how far, you know how much variation people wanted, or how much variation exists in case of pencil, is defined by something called sigma. This is called standard deviation. Sigma means this particular symbol. So how we measure? Okay, let me redefine again. So for example, if you find like pencil have very low variance, very low standard deviation, that means the variation from 7.5 is very less. That means either you get 8.5 or something like 6.5. So this is low variance. Similarly, if something is like that, very flattened bell curve, that means 7.5 is although average for 1,000 people. There are pencils which may have 2 centimeter, okay, like that. So this is 2 centimeter, and there are pencils. This is not length, okay. This is like population size. And there are pencils with 10 centimeter. This is 2 centimeter. So that much variation exists in particular measure. So this kind of data is required for analyzing what sort of portfolio do you need. Okay, so did you understand this particular concept, standard deviation and mean?
Yeah, median I didn't get.
Median is, for example, if you say if you have 10%, 10%, and if you say who is the tallest, okay, so how will you measure? You have to arrange them, right? You cannot add their, okay, you cannot add their heights. For example, these are the 10 people. You cannot add their heights and divide it by 10, and who is the, you can do that, but that will not be accurate. For example, if you have 10 people, and if you choose something like a mean, and if you add their heights and divide it by 10, you will get some value, right? For example, 178
Mhm.
is the mean. Then what will happen, that probably you will end up some value which is in decimal. Maybe some people have, you will not get an exact answer. There are people who is less than that, there are people who is greater than that. Okay, so identifying using the mean is not a ideal technique. So what you do, you use something like a median. So what we do in median, we arrange the numbers in ascending or descending order. Ascending or descending order. So you measure like this. So you measure you measure which you basically align either in ascending order, then measures, or descending order. And then you identify what is the middle value. This is more like a count. So 1, 2, 3, 4, 5. So you know exactly what is the fifth person height. So that is the median height. So median value may different than a mean value.
Okay.
So for example, no, someone, what will happen, you see, if this is like you are arranging, and suddenly a 7 feet person also stands in the queue. If you try to capture the mean, what will happen, this particular person, when you add up, this will take a much larger proportion in the sum. So for example, this is like 7 feet is 210, then the rest are 150, 130, like that, and when you divide by 10, actually you will get some mean value close this side. Okay, that's why median is a ideal technique where you arrange all of them and then try to figure out who is in the middle. So these are various ways how you can actually measure the central tendency. Okay, and sigma, that is the standard deviation, you measure like this. So you have mu is the mean, you divide it or you might subtract it with a particular population or sample value. I mean, this is going too much mathematical. Okay, and then divided by total number of sample, so you get the standard deviation. Basically, theoretically, just try to understand that one is trying to tell you what is this particular number, this is the mu, the other is trying to tell you how much variation exists. Okay. What we do in product portfolio architecture is, first we identify customer needs. Okay, so for a particular product like a watch, you might have a product need, for example here is probably the shape of a watch. Okay, then and there can be other needs also, like the material durability, battery life, all those can be needs. Then you set the priorities. Okay, so those already we taught in the, we learned in the third class probably. We use something called, what is that technique, technique mm, like dislike. Okay, so you do the like dislike method of interview, you identify customer needs, then you try to identify their priorities, and then what you try to do is try to, for a particular need, you try to capture the mean and standard deviation. So for example here the shape, so you get particular mean value and the standard deviation. Okay, next what you say is like, over a period of time, does this particular need changes or not. That means if you take this as a time, so from 2010 to 2020, does the population, so for example if for a company, marketing guy, you try to analyze this, does there a change in the mu value, okay, over time. Then you calculate mean and standard deviation for particular customer segment and for particular need also. So for example, for this particular watch, you can have three different customer groups. Probably you are trying to design something for a male, which is a adult male. You can consider someone like an elderly person. You can consider someone like a kid. Okay, so if there are three different customers, okay, then you want to now understand, for different, for all these three different needs, okay, so what are these values of mu and sigma for the different customer segments. Okay, and then you create a table Okay, okay, I'll explain these things in detail, and then you choose the architecture. So this is basically a pipeline. It is already given in your lecture 8 lecture videos, slides for from week 8 lectures. You can follow that. So what we are gathering here are three informations. One is first needs, okay, then population segments. Okay, so need means what are different needs, population segments means what are different types of population segment exist, and then we try to gather information, statistical information. One is on population and one is on these individual segments. This segment 1, segment 2, segment 3. So for the population we try to gather information on mu and sigma. Similarly for all these three we gather individually mu and sigma. Okay, and we use this information to choose a particular architecture. So let me explain how. Okay, okay, so for example, you want to design, so you get some sort of population in segment statistics, which include the population mean. If I denote it by mu and sigma, so this is population. And for different segments, you have, for example, segment 1 mu 1 sigma 1, mu 2 sigma 2, mu 3 sigma 3. So first thing you can check is like, is the population mean fixed with respect to time? That means, for example, consider a demand for a lens, like, okay, zoom lens, okay, in a camera. Now the length of, or the zoom, the capability or the length of the lens, probably the mean length, okay, mu naught, and this is mu naught. So the population mean length is changing over time. This is like in the 2010, and now in 2020 you realize that people demand more longer length of the lens, okay, to have greater optical zoom. So that means the population mean is not fixed with respect to time. So what you did together to get the population mean, so in 2010 probably you get some data, you ask, you interview people, photographers, and then ask them, okay, what is your desired length of the lens. Then people say, okay, I want 4x zoom, I want 16x zoom, and you've identified that average is 16x zoom, and 16x zooms the length should be something equivalent to, for example, 40 mm. Now in 2020 you again did that particular survey, and then you identified that now people are demanding 40x zoom. That means the mean length of the lens now it needs to be increased to 80 centimeter. So since there is a change in the particular parameter, particular need over time, that means if it is no, that means is the population mean fixed with respect to time? It is not fixed, right? It is changing. That means you will now go for a modular generation platform. So in case of camera, that's how you will go for a new generation camera. All the rest of the things are same except the lens are different. Okay, this is what we call as modular generation platform architecture. Clear?
Yeah, correct.
Okay, okay, so another thing, like once we, if it is yes, for example, population mean does not change over time, so we can take different example. For example, in case of screwdrivers, okay, you can say like the length of a screwdriver does not change over time. Okay, because or the size or the particular shape, the end point of a screwdriver does not change over time. The means particular shape. That means this is over time is a constant design requirement. Okay, so the need is constant. Okay, so mu is same over time. So then you need to ask like, is the population sigma large? Okay, that means do you have much larger variation in the requirement? When I say sigma, that means variations. So when someone is saying I want a particular screwdriver which is for M3 screws, what do you think are the variations? M3 means 3 mm. Okay, there can be screwdrivers which can be 3.01 mm or 2.99 mm. Otherwise, it will not fit that particular screw. So it will not serve the particular purpose. That means the variation is very less. We have a very steep bell curve. So where mean and deviation is almost negligible, like plus minus zero point 0.01 is the standard deviation. Okay, and mean is 3 mm. So is the sigma large? No. That means no, there is no much variation. Then we can go for fixed and unshared portfolio. That means we'll be fixing a particular design and will not be changing this across various products. Clear?
Yeah.
Similarly, if you see there are changes, okay, for example, if it is yes, population have a large sigma, that means, you know, first thing is like you already checked that over time that mu changes. Mu changes means what happens? The new mean shifts over time, 2010, 2020. That is the first checkpoint. Now you check that this is now changing. Second thing you check the new population mean, is it lot of, does it have lot of variance? That means does the values have lot of variance? For example, in case of screwdrivers, you can imagine if you have something 3 mm and here you can have something like 0.1 mm, and this is like, no, this is like 5 mm and this is 0.1 mm. So that does not make sense for a product like a screwdriver. That's why we go for a fixed unshared portfolio. But for a product where we have that particular variations, then we need to check the next particular checkpoint. Then we ask the question like, do the segment sigma equal to the population sigma? Now this is a measure for the entire population. So this particular population may have different variations. For example, in case of the watch example I gave, I told you that there can be three different segments. There can be elderly, there can be a kid, and there can be adult male. Okay. Now, for population, we considered all their data to capture the mean. But now we need to check individually, like their segment variation, like segment wise mean and variance. So for example, this is the population one, this is mu naught, and it says if we find that the variance is not equal, that means for adult we have something very narrow, we do not want much changes. Okay, and mean also can vary, change. For example, when we considered population mean, we consider the entire data. Okay, that's why we got some mu. But when we consider elderly, probably elderly mean will lie somewhere next to the population mean. This is like mu for elderly. That means the if the need is, if need is size, size of this particular dial. If it is, for example, if I say like I'm analyzing this as a area. Okay, so elderly may require a larger dial size. Okay, so population mean for a particular segment elderly will be higher than the population mean. However, for a kid it is smaller, and that's why you get a average of population mean. Okay, adult you can consider same as the population mean. Okay, so you see here, like, do you have some sort of variations? So if the population mean and this particular adult variance does not match, that means we need to make different products for each particular category. Okay, so we'll go for modular product family. Okay, and if we say like the population variance, which is like that much width, and a adult variance is also that much width, okay, and your kid also have that much width, that means what? A single particular design will not fulfill different customers. Okay, although population mean by adding and dividing by 3, you are getting the same mu naught. This is mu kid, this is mu adult. Since they have lot of different variations, you go for something like a adjustable portfolio architecture. In adjustable, either you prefixed prior to your design, you take customer measurement and then design particularly for kids something, or you design something generic, but it should be adjustable for anyone in the family. So that's how you go for adjustable portfolio architecture. Clear?
Yes, yes.
So this is an example. I think your assignment also have something similar. Not the same example, but I'm trying to give a example like how you need to go ahead with this sort of questions. So you will be given one product, and I took the same example. So you are given certain needs. Okay, so these you gather from your interviews or from surveys. So you can consider survey or interview to get all these information, and you understand that the customers have four, you know, one, two, three, four different needs. One is dial size, okay. One is dial shape. One is cost and material. So size means area. So when you a need needs to be converted into something into specification, which needs to have a matrix and a value. So it needs to be area, something like a value plus centimeter square, and shape can be qualitative like a rectangular or circular. Cost can be like price rupees something, and material quality can be, it can be both qualitative and quantitative. Okay, you can define this in terms of strength of material as quantitative value, or you can define this in terms of qualitative values also, like something which as a designer or as an architecture you may know, like you can shiny, may looks like good, like colorful, like that. Okay? Those are qualitative parameters. Next, what you do is like you prioritize these needs. So these are again captured from population survey. So you understood like dial shape is the most important, high priority thing need. Material quality is again the high priority need. Cost, maybe people may compromise on the cost a little bit if you provide a higher material quality and dial shape. Similarly, dial size is also a little bit compromisable if it is a in the, if you consider the other parameters equally. Then you try to capture the various uh, customer segments. So how you capture this? What you do here, like when you generally do a customer survey, initially you take all the inputs from various people, right? Okay. Later based on certain parameter. For example, you consider age a parameter. While taking the survey, you consider that, okay, please tell me your age also. Okay, for 7 year, someone said age is 65. So based on those categories, you later may identify that, okay, some sort of clustering can be done on these population informations. Okay, so that's how you actually categorize the customers into three categories. So this is basically the variation in terms of need. So there are four needs. So you will have four such, population data, and depending upon that you may identify that, all the four needs can be categorized or clustered into these three customer segments. Okay. Okay, so then what you do, you make a table out of it. So you keep need at the extreme left side, and then you write down the population mean. For example, the dial size, if you consider area. Okay, so if you I already told you how to, measure mean. You basically add up all the dial sizes in your study and divided by number of studies, you get the population mean. Similarly for sigma, I told you, like, you need to, no, do this particular use this particular formula. So you need to use mu, population mu, minus a particular population square, like that, sum. You took a square root and divided by n. N is the number of population. So this gives you the standard deviation. So what you measure here is you measure standard deviation for the dial size. So mu dial size. Okay. Similarly, this is sigma dial size population. Okay, like that you take the all different measures. Material quality can be qualitative. So there you take mode. For mode, you try to capture the frequency. So how many people says that, you want the colorful ones probably. So material quality may be also like metallic. Okay, you may have different variations, and you identify, for example, when you did a survey for material quality, you can later classify your finding that, metallic, then some people may say rubber, some may say like, plastic. Okay, and you identified the metallic has the highest frequency, so you consider that as a mode. So here you population mean you captured as mode as a metallic. Again deviation, you say metallic, plus minus you said rubber, that percentage of rubber, people say that percentage of people say plastic. Then next what you do, you consider the segment wise mean and the sigma. So for segment wise, for example, this is adult male. For a size, for example, if the population size is 50 centimeter square, okay, and population sigma is 5 centimeter square. Okay, this is just the area, I'm defining this by area. Okay, that means 50 plus minus 5 centimeter square sigma means. So adult male may require something, maybe greater than this, so they may say 55. Sigma can be again plus minus 10 centimeter square. Then the customer segment, next customer segment was adult female. So for a female, probably they may want something like a smaller size because they have a smaller wrist size. So they may say 45 and plus minus, 5 centimeter square. Similarly for a kid, it is maybe even less, 35 centimeter square plus 5 centimeter square. But when you add this all the three sigmas and divided by 3, you will end up getting this particular 50 centimeter square, which is the population mean. Okay, so similarly you fill this particular table and you use this sort of decision tree to make a decision what sort of architecture you will be requiring. Clear? So for example here, for example for dial size, you said like population mean is fixed with respect to time. So you consider like you take that survey in 5 years ago, then 2 years ago, then this year, then you said like okay, the size of dial size did not change. So this is for dial size. So for dial size, you said it is fixed over time. Okay. So is the population mean fixed? Is the population mean fixed with respect to time? No. No. That means yes. So it is fixed with respect to time. Then you go for the next. Is the population sigma large? See, sigma here is 5 centimeter square. Okay. You said okay, sigma is 5 centimeter square. It is not very large, but 50, then 5, 55, then you say 45 plus minus 5. Next you ask if it is very narrow. Actually if it would be very narrow, that means there is no variation. Okay, for example you said 50 means population variance is 50 only or 51 only. That means your entire population need only one particular size of dial. Then you go for fixed and shared portfolio. That means you can just alter only one particular only one fixed, only one size of the dial. Okay, and then you can go ahead in the market. Okay, so these are particularly specific to particular need. Okay, so need one by one you need to go ahead with this particular checklist. Then if you say okay, this is not population sigma is a bit large, this is like 5 variation, let's see the next you see like okay, do the segment sigma equals the population sigma. Now for here you see first your male, you say male now have a greater sigma. Okay, this is your population one. Now male mu is more and also it is broader. Okay, for female it is small, less, mu is less, but again mu is same. Sorry, the variance is same, standard deviation is same. Okay, this is for male, this is female, this is your population. And for kid it is it is again 5 centimeters, so standard deviation is same but mu is even small, so 35. This is for kid. Okay, what you need to check here is like you need to check here is the sigma equal to the population sigma. So now you need to go again one by one for each segment. For male, if you see the particular variance is more than the particular this thing, the population sigma. That means you need to go for adjustable portfolio architecture. That means in order to address different male population, you need to provide different dial size. So there should be some sort of customizable, whether it is customizable at the point of manufacturing or later something like adaptive design you need to consider for male population. For female population, since it is not a for female and kid, the variance sigma is not different to the population, you can go for modular product family. That means you just consider one particular design for female, one particular design for male. Okay, having some sort of other modular, other components. Okay. Clear?
Yes. Yes.
Okay, so if you have any question, please feel free to ask. And this is the end
Yes,
of
sure.
this class.
Okay. Thank you.
Okay. Okay. Oh, sorry. This is something. Okay. Thank you for this class, for coming to this class. So tomorrow is a deadline for the assignments for week 8 lectures. And if you have not finished yet, please finish your assignments. And the next class will be next Tuesday, same time. Okay. Thank you.
Thank you, sir. Thank you.